About 10. All right, so we are going to do Riemann sums. Now this kind of seems like a thick packet, but it does just take up a lot of space. This is probably, if there's anything you remember, I think this might be something you remember pretty well. Hopefully you remember all of it, right? But this is something students tend, or if they don't remember it, they're able to figure it out. But I'm going to kind of go through this first page. And so they always give you some information. And here, it's still about velocity and acceleration, but Riemann sums are going to pop up in this question. Then they tell us that velocity is decreasing. That's important, or could be important. Like, we can look at these velocity values, 5, 3, -1, -8, and we could say, well, duh, they're decreasing. But what I don't know is everything that's not on the table. I don't know what's happening at T1. That, the velocity could be going up and then down and up and down and all that kind of stuff. But they go ahead and tell us the velocity is decreasing, and if they say it, it's probably important. What got hole punched out here is just that we're on a time interval 0 to 10. So number 1 says, is there a time t when the particle is at rest? What do you think? What does at rest mean? So at rest would mean where v equals 0, and even though they don't say v equals 0, when must v equal 0? Yeah, right here. V is 3, v is -1. This is a continuous graph. I know that because they tell me. And so they tell me that it's differentiable, which implies continuous, and so we can say yes. During 2 to 6, because v of 2 is positive and v of 6 is negative, so v of t must equal 0. All right, go to the next one. At what time indicated in the table is the speed decreasing? So before we even really get into the answer, tell me, what do we know about speed decreasing?
So different signs.
It's velocity and acceleration. One's going to be positive, one's going to be negative. And it doesn't matter which one's which, but they have to have opposite signs. So look up at the table and tell me, at what time does that happen? At t equals 2. So at t equals 2, because v of 2 is positive and v of 2, or whoops, sorry, a of 2 is negative. Opposite signs. Now, one thing you might have noticed on this is I pretty much tell you to explain your answer on every single one. That's not really how it'll be on the AP test. You won't have to explain every one. This is just on here a lot, so you can just really get used to writing it out, figuring out how to write out your answers. Okay, here we get into the Riemann sum. So I'm going to change colors, and they always tell you which kind. Now, what shape are Riemann sums? It could be a trapezoid, which if they want you to use a trapezoid, they will specifically say trapezoid, like how they're going to do it in 5. So what other shape? If they don't say, what do they really mean? Rectangles, okay? So we're talking about rectangles with a base and a height, and that's what you're going to have to figure out. So approximate, I'm going to go ahead and write this, and I'm going to write the approximation symbol. All right, and I'm going to kind of go through this without graphing. For some of you, I think graphing would make it really clear, okay? But I think a lot of you don't need that. And time, you don't want to spend a lot of time doing something you don't need to do. So when I'm looking at this right here, okay, this is going to be my first rectangle. Okay, first of all, I'm going to cross out acceleration. I'm going to have to erase that later, so don't cross it out too dark. But I don't really need to know anything about acceleration right now. I just need to know about velocity. Okay, 5 and 3 are the possible heights of my rectangle. They tell you to use the left Riemann sum. So I'm going to use 5. 5 is going to be the height of my rectangle. What's going to be the base of my rectangle? 2, right? Because t equals 0 to t equals 2, that's a shift over of 2. And then I'm going to add it to the next one. Okay, and I'm going to go ahead and just use a different color here just to make it really clear. Okay, cross out acceleration, we don't really need that. And between 3 and -1, I am going to choose the number on the left. Again, because they say it's a left Riemann sum. So that is the height that we're going to choose, and then we're going to multiply that by the base. And if we're going from 2 to 6, that base would be 4.
Can you repeat how you got 3 then?
So in the rectangle that connects the point 2, 3 to 6, -1, the height is going to be one of the two y values, one of the two velocities. Since they said use a left Riemann sum, you use the left point, the point that's the earlier one. If they had said right, we would have chosen -1 instead. Okay, so then I'm going to go and change colors again. We have one last one. And again, we're not looking at acceleration. Which number am I going to choose? -1. And it's really easy to choose 6. But 6 is the t value. So I got to think about which one is the left velocity. That is going to be -1. And I'm going to multiply that by whatever the base of my rectangle is, which is going to be the difference between 6 and 10. If you were to have actually plotted these points, what I did was it would be super crystal clear. It would just take you time. So if you can do it without graphing, that's the best. If not, then you got this. Okay, so this turns out to be 10 plus 12, 22 minus 4, and that's 18. This is a non-calculator problem, by the way. If you cannot multiply and add these numbers accurately, don't do it at all. You could have left it like this. You don't have to simplify in the free response. Most of you naturally are going to do that as often as you can, but like if this got even messier, we would definitely not want to try to simplify if I can. Okay, so it says explain the meaning of the definite integral. All right, so when you integrate velocity, what do you get? When you integrate velocity, what does that give you?
Position.
It gives you position. So 18 has to do something with position. Is it the current position? Is it the change in position? Is it the total distance traveled? What is it?
It's displacement.
It's the net displacement. So you could say the net displacement of the particle is 18 units. An easier way to think about this, and I think more people would probably say something like this, the particle is 18 units. Now there is a direction here. It would have been possible to have a negative answer. And that would have told us that this particle then would be so many units to the left of where it started. Since this 18 is positive, we need to go ahead and say to the right. And it's not so much of 0, because we don't know where this thing started. They didn't give us that. So we just say to the right of the starting point. It's not the only way we could have said that, but that's one way to say it. And then the last thing we got to include is the time. Okay, so the particle, oops, I should have put a verb in there, is 18 units to the right of the starting point at t equals 10. Because this would have been different if I had had you integrate not to 10 but to 6 or something else. Typically, though, you do integrate the full table, but that is something we would need to watch. If this had only said 6, I wouldn't have even had this last part right here. Okay? That's atypical, but it could happen. Alright, is the approximation found in part 3 greater than or less than the actual value of the definite integral shown below? So what they're saying is, if we were to graph this and really find the area, okay, or if we had an equation and we actually like integrated and plugged the numbers in, the true real answer, is this approximation greater than or less than that answer? What do you think? It is one of the two. Which one? Okay, so we're kind of half and half. I am going to over here, actually I'm going to do this up here. I'm going to plot the points, not all of them. This is where a graph is really helpful. And I'm going to plot velocity. So 1, 2, 3, 4, 5. Okay, so there's a point right there. And then 2, 3 within the next point. So keep in mind that if I connected these, that area below is the true answer. Which point did I pick to say is the height? The left. So what I'm finding is the area of this big rectangle, but the true answer is really just underneath the curve. So is my estimation greater than or less than the true answer? Greater than. Once you saw a picture, it was a little bit more obvious. Okay? So we're going to say greater than.
Are left Riemann sums, if they're not trapezoidal, are they generally always greater?
It's not that the left is greater. It has to do with the fact that this is left and decreasing. If the points had been increasing and we had done a left Riemann sum, the approximation would be less than. So this is kind of a weird thing to memorize. I think maybe do what I did, where you just graph it and just think, and is this picking all the biggest heights bigger than really what we had? Because that's what your explanation is going to be. Greater than, because v of t is decreasing. And that's why they had to have that in the beginning. Okay? You don't have to say v of t is decreasing and it's a left Riemann sum. Left Riemann sum was a given, and I guess v of t is decreasing is given as well, but this is sufficient to say why the left is bigger. All right, so look at what's happening on 5. The only difference is the absolute value. So what is that? I'm going to ask you for the meaning first. What are we going to find when we do this? The total distance traveled. So we can go ahead and say that. Total distance traveled. I still need to put the time. So I can say at t equals 10. That's really a sentence, but either way. That's what the meaning is. All right, now, in order to approximate it, we showed, I showed you guys how to do this without the calculator, but to algebraically do it and with the calculator. But this is going to be Riemann sums. We haven't done this yet. So absolute value just means we're going to make all the velocities that are negative positive. So that's all you really got to do here. Okay? Now, if we were doing a left Riemann sum, the only thing I would need to change is this -1. I would need to change it to +1. But they throw in something else. They say trapezoidal. Okay, so we're going to have to do a trapezoidal, and I'm going to erase all this because it's kind of hard to read now. I still don't really need acceleration though. All right, so I'm going to do trapezoidal, which means I'm still going to look right here, but instead of picking 5 or picking 3 for left or right, I'm going to average 5 and 3. Okay, so we add up 5 and 3, we divide by 2, and then again, you multiply by the change in time, which would also be 2. Okay. I'll come back now, and you still need to copy that. So then, we look at this one. Okay? Instead of picking 3 or picking -1, we're going to average them, but we need to change that to +1 because we're doing absolute value now. And the subinterval is still 4 units, just like how it was before. So I'm going to do 3 plus 1. So notice I didn't do -1. -1 would be if I was just doing a trapezoidal up the old way. All right, times 4. Why don't you see if you can write down the last one on your own? All right, pretty good. So this is a little bit more to do. You don't have to simplify this number. Although it would really not be that hard to do, because that's going to be 8. That's going to be also 8, so we got 16. That's going to be 2 times 9. And so what's our total? Yeah, I think it's 34. But here's the deal. If you just had left your answer the way it was, you would have got the points. If I had all that, but then wrote down, say, 32, I lost that point. So you just got to know your own number crunching. And time-wise, it's probably not even worth it to do that. But we know that some of these are multiple choice. Again, that's why I just want to make sure you're able to do it. Okay, so finally we get to acceleration. We're going to determine the value of the integral of acceleration. Now notice it does not say approximate. So really, here's what I know about Riemann sums. Riemann sums are approximation. This tells me I'm not doing a Riemann sum. Right? So what is this going to represent? Because if we know the meaning, that may actually help us find it.
The derivative of velocity.
So it's the derivative of velocity, and we're going to integrate it. So what is our result going to be?
Velocity.
Velocity. What about velocity?
Change from 0 to
The change in velocity from 0 to 10. Can we figure that out without doing a bunch of calculus? Look at the table. Look at the velocity at 10 and the velocity at 0. Can you figure out the change? I mean, technically what you're doing here is doing v of 10 minus v of 0. This is sort of like second fundamental theorem of calculus. This is sort of like that. I'm not going to say it is exactly like that. So negative 8 minus 5, and you didn't have to show, you would not have to show that here. Okay, you'd have to show this, and you would have to explain the meaning. So the velocity decreased by 13, and you could say, you know, we said at t equals 10, but we can say from t equals 0 to t equals 10. You could say over the interval 0 to 10. So this one was actually the easiest one to do, but it was the hardest one to figure out, because if I'd let y'all kind of just figure this out, you probably would have tried to Riemann sum, probably. And so we didn't really even use that last column, or row, which is really weird. So, okay, let's go on to the next page. Okay, here we have another table, although these questions are all a little bit different. So it says a particle moves along a horizontal line with positive velocity and differential and all that other stuff, and then they give us units. So we're going to have to use units here. When they don't give you units, you don't have to put units. But if they give them to you, you've got to put them. And I will say that generally they'll put stuff like this when you're going to lose a point if you don't put it. I would always put units though. But if it says indicate units of measure, that means they're probably going to qualify a point just for that. Alright, so based on the table, what is the smallest number of times at which the velocity could equal 20? Who? Twice, I agree. When?
0 and 2.
Between 0 and 2, we should have a 20 for decreasing consistently. Yeah, right here, we should have another 20. Okay, so how can we justify this? Well, we can say v of 0. It's hard not to get real wordy with something like this. V of 0 equals 37, decreases to v of 2, which equals 17. So v of t must equal 20. And I'm going to go ahead and say centimeters per second. And v of 10, which equals 17, increases to v of 12, which equals 38. And maybe the so part can go at the very end. I will say this about the explanations. I've told y'all when they really want to see one specific thing. on a lot of these explanations, as long as you're using calculus, there's more than one thing that they might accept. Don't not justify your answer. Justify your answer. But just do it the way we've done it, and I wouldn't stress out much more than that. All right, what about B? Based on the tables and the value, what's the smallest number of times the acceleration would equal 0? So they don't give us acceleration, but can we figure out when acceleration is equal to 0? So V prime is equal to acceleration. So when is the rate of change 0? Or is it? Keep in mind that what this looks like is it goes down and it comes back up. Now, it may be doing a whole bunch of down and ups, but what's happening somewhere? I don't know if it's really happening right at 6, but what's happening right there? There's a minimum. Does there have to be a minimum if V of t decreases and then increases? Yeah, that's like the definition of what we have when we have a minimum. And so V prime must equal 0 right there. I don't know where it is, but if it increased and decreased and increased and decreased, and they showed that, I would have to count up however many times. Maximums would count as well. So at least once. You could just say once. That would be okay. Because V of t decreases, then increases. So V prime of t, which is equal to A of t, equals 0. And you could say at the min. That would be okay. You probably leave that part off as well. All right, average acceleration. Use that word average. There's very few things that they're asking you to do. What are they asking you to do here? A-rock, how do you know? Because it's average, but an acceleration is the rate of change of what they give you, which is velocity. So they're asking you for average rate of change, which remember is slope. The whole reason I bring this up is because I want you to see when you're supposed to do Riemann sums and when you're supposed to just do the slope. Here, you are supposed to just do slope. If you do anything else, you're not going to get the points, and it's kind of a shame. You do have to show this. I've mentioned this the last few days. You got to show that stuff. V of 10 looks like 17. V of 8 is 6. So you end up getting 11 over 2. And we need to put our units on here, which is centimeters per what? Second. How do I know that? Because it is acceleration. If by chance this is a 2-point part, 1 point is going to be given for this, and 1 point is going to be given for the correct answer with the correct units. So let's say you thought, I don't need to write that. I can figure out in my head that it's 11 over 2, and you write 11 over 2 centimeters per second, you've gotten none of the 2 points, even though your answer is correct. You just need to be careful with that kind of stuff. The units have to be right especially when they ask you. Okay, midpoint Riemann sum. Midpoint Riemann sums only come from tables. They're not going to have you calculate the midpoints. They're going to be given to you in a table. They do say 3 subintervals. So if the whole thing is to 12 and have 3 subintervals, how long is each one? 4. Okay, so look, there's my first one. This distance is 4, and left Riemann would be 37, right would be 5, trapezoid would be average the 2, but when you get midpoint, you pick the middle number. This is the only time you do that. So 17 times 4, that would be the first rectangle. Okay, what about the second one? Yeah, 1 times 4. And since these are of equal length, we know it's always going to be times 4. And the last one? 17 times 4. Now this is not difficult to do. I mean, elementary school children could do this, so I know you could. But time-wise, chances of making a mistake, you may not want to simplify that. Okay, that is your answer. Okay, you do need to maybe do this and then write the units, which would be what? Okay, we integrated velocity, which means we went back to what? To position. So it's just centimeters. And that helps us know what we're trying to find, because they want us to explain what this is. Remember, when you integrate velocity, you're either going to get net displacement or total distance traveled. Which one is this? Net displacement, because there's no absolute values. Okay? So we could say particle is, and then if you wanted to calculate this, or if you wanted to rewrite it, anybody already calculate it? I can't remember. 34, 96. I feel like I'm horrible at my mental math today. Okay, anyway, I'll just go ahead and do what most of you do. You could just do this. It's totally fine. You will not get points taken off for this, which I know it seems weird. To which direction, right or left? To the right. So starting point, or you could say this is the net displacement. That would be a little bit more concise way of saying that. And you got to put in the time at t equals 12. And since they gave us units, we need to go ahead and use seconds. Okay, the only other thing that I want to talk about, and this really is kind of like, if you know you're shooting for a 4 or 5, you need to listen to what I'm about to say. If you know that there are certain parts you're just not going to get and you're okay with that, I give you permission to kind of zone out or just work on your homework or whatever. Because there's one more time average is used, okay? And this right here is a perfect example. So if you turn the page, I'm not going to go through these problems, but I want to show you a difference. All right, now when you're given a rate and you integrate that rate, you no longer have a rate. Like if I integrated R of t, I should just have gallons. Integration is going backwards, all right? And so if I integrate R of t, I should just have gallons. So if I'm talking about average rate of water, it's not average rate of change because this is the rate. So I'm not like trying to take the derivative or do slope. I'm not trying to integrate with Riemann sums. And in fact, what I'm trying to average is exactly what's given. When that happens, this is talking about average value, which is the whole 1 over b minus a to b, f of x, dx. You remember this. I mean, we've gone over this. So in this case, you would, because you're trying to take the average rate, and really you're trying to take the average rate of this, but it's still a rate, okay? This is still a rate. You've got to have 1 over, in this case, 24, and you got to integrate 0 to 24. Now, if you forget, let's say, the 1 over 24 part, that's totally understandable. What will happen is you will get a number that's considerably bigger than all your other numbers, and you'll think, this doesn't make sense. Whatever you get for the average rate should be pretty close to R, these R values. It should probably be like 10 or something like that. You're going to get like 240 something. I don't remember what it is. And that could be a way you know you should have this fraction. Okay, so let me show you one other time this happens. Actually, one more page than this. And this is not something that's going to make you like pass or fail the test. But again, if you're wanting a 4 or 5, especially if you want a 5, this is something you might want to know. Because it's not that hard, but it is a small thing. So notice here, they're not giving me a rate. They are just giving me the water temperature. All right, so W prime of 12, that's going to be approximate. That's average rate of change. Okay. But on B, it says approximate. So again, we've got average rate of change. We got Riemann sums. But they say average what you already have. So do you see what I'm saying? You're not taking the rate, you're not given something normal and trying to find a rate. You're not given the rate and trying to find something normal. You are trying to find exactly what you're given. If they ask you to average that, you're going to use this average value, which in this case would be 1 over 15, and you would integrate 0 to 15. So in other words, the big difference here is that you got to divide basically by your time span. Your answer will not make sense at all if you don't do this. So on this one, average temperature all in the 20s, pretty much. If you forgot the 1 over 15, yours is going to be way bigger, like 200 something, 300 something. Okay, so that's a way that you can kind of remember this. So there you go.